Hey, so in this video, we're just going to have a quick look at the renderer effectively that we have inside of Unreal. So I call this, again, this slight comparison with V-Ray and what we call the deferred versus the forward rendering. So just to explain, here we've got this scene rendered in V-Ray, and the way V-Ray works is when you have an image, you have a camera in the scene and you want to render the image, the renderer is going to fire a ray from the camera. When that ray hits a surface, it will query the point and see what's happening, what lights, what materials, and what neighboring points we have, and return it back as a rendered pixel. And that's my understanding of it. It doesn't have to be accurate. It's just something that's helped me greatly understand how Unreal works. So it's just to make the comparison with here in Unreal, we see that this is the buffer visualization in Unreal, and we see that it's actually separated out all these layers. So we've got the roughness, the base color here, the specular, and then there's all these other layers that I can't choose, but it's just an illustration that we've got all this stuff that's effectively laid on top of each other. So this is how Luis Cataldi from Epic Games explained it to me. It's a little bit like Unreal has actually got 7 renderers stacked on top of each other, contributing to that final pixel color. So the way I see it is a little bit like we are compositing in Photoshop. So when all the layers are separated out and then put back into Photoshop to do the final image, effectively, that's, as I understand it, that's how Unreal does it under the hood to create this final image. So here we've got the passes, Z depth, and that's occlusion that we're familiar with. So how does that actually work in practice? Well, the lighting is made up of several different elements which are going to act as these so-called layers. Again, it's not literally like that, it's just an illustration to understand how it works under the hood. So we've got our skylight, which is going to give the sky, as its name indicates, illumination from the sky. We have different ways of doing that. So we'll have the sky, the Unreal default sky, which is a blueprint. We can use an HDR, of course, that will probably do most of the time, but we also have other types of blueprints which we look at in the course, and then we can also use cube maps, which is a somewhat old school device but still used mainly in games today. So that's for the environment. What's a little bit new for us is that the environment is going to affect the scene like in this layer fashion. So for example, the fog will also affect the illumination of our scene, unlike it does offline, because we will be compositing the fog afterwards mainly. So here we've got the direct light. So these are the new, for those of you not familiar with Unreal, there is no sunlight per se in Unreal. So this is our sunlight, the direct light being all the rays coming from the light will be parallel as opposed to the spotlight. Then we've got our light mass. So the light mass is when we will calculate the light bouncing off objects onto others, and we will press that build button. So this is what will take a long time, potentially several hours to calculate. But then we're done and we can roam around without calculating this anymore. And so this is completely new for us in Unreal, is that we have to have these reflection probes. The reflections are things which are very costly to render in time. So Unreal Engine have got this very effective technique of placing reflection, so pre-calculate cube maps effectively from this certain point in space, which will then be applied to the reflections. And a lot of the time, because we've got blurry reflections, these work very well because they just give you an indication of what's around the object. On the other hand, they fall short of what we need in architectural visualization, which is a lot more accurate reflection. So for that, we've got our screen space reflections, which work very well, and then we've got the planar reflection. So it's a little bit of a overlook to not talk about post-process when we talk about lighting, because again, in the traditional workflow, we will do all our post-process, color correction, and so on in Photoshop. The tone mapping will be done automatically by V-Ray when we apply, whether it's exponential, Reinhardt, and so on. So tone mapping may be done automatically for you. So this is something that is done in Unreal, but because it's all in the same package, we have the opportunity to have more of this back and forth, going from the lighting to the post-process and keep tweaking both. Whereas in the traditional offline workflow, if we do our lighting and then render and do our color correction, we won't be happy, or whoever's done the color correction won't be happy if the lighting's changed. And then we've got to re-render and possibly tweak the post-process again. So here, it's all in the same package and it's a lot more friendly to the process.